Welcome to the DIY Honda Garage channel. The DTC, or Diagnostic Trouble Code P0651, indicates a sensor reference voltage B malfunction in Honda Civic models from 2016 to 2021. This error typically triggers when the onboard diagnostic system detects an abnormality related to voltage provided to various sensors used for engine management and vehicle operation. In Honda vehicles, this DTC is monitored by the Powertrain Control Module, PCM, which ensures that necessary sensors receive the correct reference voltage to function properly. A malfunction in this voltage reference can affect functions including timing, fuel delivery, and emissions control. Understanding DTC P0651 involves recognizing its importance in the overall diagnostic process, ensuring that engine and vehicle performance meets the required standards. The subsequent slides will provide a thorough examination of the problem. Potential causes, symptoms, and troubleshooting steps to effectively resolve this issue. The DTC P0651 reveals a malfunction related to the signal quality of the reference voltage provided to several critical sensors in the vehicle. These sensors include the camshaft position, CMP sensor A and B, turbocharger boost sensor, accelerator pedal position APP sensor, AC pressure sensor, fuel tank pressure FTP sensor, and the neutral position sensor. Each of these sensors is integral to the vehicle's performance, as they provide vital information to the PCM for regulating engine operation, boost control, and other functions. Their locations vary. The CMP sensors are typically situated near the engine block, while the APP and turbocharger sensors are positioned within the engine compartment. If any of these sensors fail to receive the correct voltage, the vehicle may experience performance issues such as stalling, decreased power, or increased emissions. Consequently, understanding where these sensors are located and what functions they serve is crucial in diagnosing the implications of DTC P0651. There are several potential causes for the triggering of DTC P0651. First, improper connections or loose terminals at the PCM or other related parts can generate intermittent failures. Such loose connections may lead to a poor or unstable voltage reference for the sensors involved, causing the vehicle's diagnostic system to signal a malfunction. Second, short circuits in the wiring, particularly within the VCC lines, can disrupt the intended voltage pathway that is crucial for sensor operation. Lastly, defective sensors themselves, such as the CMP or APP sensors, may not function correctly if they have internal faults or were incorrectly installed. Diagnosing these causes systematically is essential for identifying the root issue behind DTC P0651 effectively and ensuring a comprehensive resolution. The symptoms associated with DTC P0651 can significantly impact the driving experience and vehicle functionality. Common indicators include noticeable engine performance issues, which may manifest as rough idling, poor acceleration, or unwanted stalling of the engine. The vehicle may also exhibit a loss of power during acceleration, affecting the driver's ability to maintain a smooth driving experience. Additionally, the check engine light is likely to be activated on the dashboard, alerting the driver to the existing issue. These symptoms can be alarming for drivers, and it's essential to address them promptly to prevent further complications. Therefore, understanding these symptoms is critical for diagnosing and resolving the underlying cause of DTC P0651 effectively. The first step in troubleshooting DTC P0651 involves preparing the vehicle and diagnostic equipment. Begin by turning the ignition key to the on position without starting the engine to power the vehicle's electrical systems. Next, use the Honda Diagnostic System HDS to clear DTCs stored in the vehicular computer. This step is crucial as it resets any error codes, allowing for a fresh diagnostic evaluation. Then, recheck for pending or confirmed DTCs with the HDS. If DTC P0651 is indicated again, it confirms that the issue persists, directing you to proceed with the next steps in the troubleshooting process. If not indicated, it suggests an intermittent problem, potentially arising from loose connections or temporary faults in the sensors and wiring. In this second troubleshooting step, you aim to narrow down the possible failure area by disconnecting specific connectors associated with the various sensors involved. Start by turning the vehicle to the off-lock position to ensure safety during the procedure. After ensuring safe conditions, disconnect connectors for components such as the CMP sensors, turbocharger sensors, APP sensor, among others. Once all these specified connectors are disconnected, turn the ignition back to the on position. Now, clear the DTC using the HDS again and check for pending or confirmed DTCs. If DTC P0651 appears, it indicates that a fault exists within the wiring or the components related to the sensors you just disconnected. If not indicated, this might suggest that the issue resides in the remaining wiring for the PCM or in poor connections. The third troubleshooting step involves systematically reconnecting the previously disconnected sensors, one at a time, to isolate which part may be causing the DTC P0651 to trigger. Start by reconnecting the CMP sensor A, monitoring the vehicle's diagnostic system for any changes in DTC status after each reconnection. It's essential to use the HDS for this process and check for pending or confirmed DTCs. Should DTC P0651 reappear after reconnecting a particular sensor, it signifies that this sensor or its wiring is likely at fault and should be replaced or thoroughly inspected for issues. If after reconnecting all sensors, P0651 does not return, then you must explore connections to the PCM or other components that were previously overlooked. Thus, this methodical approach is key to pinpointing the exact source of the fault. Step 4 focuses on identifying potential shorts in the wiring from the VCC lines to ground. Begin by powering down the vehicle to the off-lock mode, ensuring all electrical systems are inactive to conduct safe testing. You will then jump the SCS line using the HDS, allowing the system some time to stabilize. After waiting for over a minute, disconnect the PCM connectors A and E, which interface directly with the vehicle's sensors for data flow and voltage supply. With these connectors unplugged, you can now check for continuity between the individual test points for each relevant connector and the body ground. This process helps identify any instances where VCC wires may be incorrectly grounded, which would create a short circuit condition. If continuity is found, repairs or replacements will be necessary on the identified wiring. In the final troubleshooting step, the objective is to assess the voltage from the VCC lines to determine any shorts to power. As with the previous steps, ensure the vehicle is powered up by turning the ignition to the on position. Again, ensure that the connectors for the CMP sensors, turbocharger sensors, APP sensor, and others remain disconnected during this test. Measure the voltage of the test points via the HDS or a multimeter to see if there is an appropriate voltage supply from the PCM during operation. If voltage is present where it should not be, it may confirm a short to power, necessitating repairs on the VCC wiring related to the identified sensors. Alternatively, if no voltage is detected at these points, it may suggest that the VCC wires are in good condition, thereby directing attention to the PCM itself. In that case, Consulting authorized service information or replacing the PCM would be the recommended course of action. After completing the troubleshooting steps and making necessary repairs, it is crucial to verify that all systems function correctly. Start by using the HDS to confirm that no DTCs are present after repairs on the vehicle. This ensures that the faults have been effectively resolved and that the PCM is communicating appropriately with the sensors. Next, check the functionality of each sensor that was disconnected or suspected of being faulty to ensure they operate within designated specifications. Observing normal engine operation is vital. It verifies that power delivery and sensor readings are aligned, contributing to optimal vehicle performance. Conducting these checks is not just a formality. They are essential in ensuring that we've achieved a long-lasting resolution to the DTC P0651 issue. Preventive maintenance plays a key role in minimizing the recurrence of DTC P0651 and similar issues in the future. Regularly inspecting electrical connections and terminals for any signs of corrosion, wear, or looseness can significantly reduce the likelihood of connection-related failures. Employing quality replacement parts during repairs also ensures that the system remains robust and resilient against future issues, as inferior components may lead to more frequent failures. Additionally, it is wise to consult any service bulletins or updates related to the PCM and the sensors involved. Staying informed and proactive can help maintain vehicle health, performance, and longevity, thereby reducing long-term repair costs and improving reliability. In summary, DTC P0651 highlights a critical malfunction in the reference voltage provided to key sensors in Honda Civic models from 2016 to 2021. Through a structured troubleshooting approach, including careful inspection of connectors and testing of VCC lines, technicians can effectively identify and remedy the underlying issues. Understanding the roles of each sensor and the implications of voltage faults is essential for troubleshooting this error code. Furthermore, implementing preventive maintenance measures can help mitigate future occurrences of DTC P0651, ensuring that the vehicle remains in top condition. Following these thorough steps ultimately leads to enhanced reliability and performance, establishing a solid foundation for trouble-free driving. Please like and subscribe to the channel. See you next time.